So the fact that PGC1 alpha was post-translationally modified was actually discovered very early on in the history of PGC1 alpha. So even before we knew that it was activated by exercise, we can see that Perry Pigsiever here had discovered that PGC1 alpha was phosphorylated. And it was phosphorylated by this protein kinase P38. So P38 is a MAP kinase that's activated by different stresses within the body. So it's a stress-based kinase. And the way that P38 usually works is it usually phosphorylates three residues, serines or threonines, that are very close together. And so when the first one becomes phosphorylated, that allows the kinase to then dock on and phosphorylate at two separate sites. And in PGC1 alpha, they identified these three sites as threonine 262, serine 265, and threonine 298. And you don't have to remember the exact numbers. But what they did here is they did a simple experiment where what they did is they added an activator of P38. So this is MAP kinase 6. And so what MAP kinase 6 does is it's upstream of P38 MAP kinase. So a MAP kinase is a protein that phosphorylates a MAP kinase. And so MAP kinase 6 phosphorylates P38. And so what they did is they did a simple experiment where they took the wild type P38 and they added MAP kinase 6E, and you can see that when they did that and they added radioactive ATP, the MAP kinase 6 took the radioactive ATP and added it to P38, or it phosphorylated P38, and in turn P38 took the radioactive P30 or ATP, took off the last phosphate, and they added it to PGC1 alpha. So when they looked using just using a normal radiograph, and they ran a gel and they looked at the phosphorylation of PGC1 alpha, what they found is when they then looked using radiography to see where the ATP, the radioactive ATP, had been added, you could see that there was an increase in the addition of P32 into PGC1 alpha. All right, so wild type MKK6 with wild type P38 causes the phosphorylation of PGC1 alpha. When they mutate this threonine 298, doesn't really affect anything. When they mutate these two sites, the 262 or 265, it actually maybe increases baseline phosphorylation, but it doesn't really affect the activation of, or the addition of the phosphorylation by P38. You only really see it when you get rid of all three of these sites. When you mutate all three of these sites, now you activate P38, now you don't see the phosphorylation of PGC1 alpha. So what this data is telling us is that when you activate P38, you get an increase in the phosphorylation of PGC1 alpha, and the increase in phosphorylation of PGC1 alpha happens in this region around between 250 and 200 and 300 amino acids within the PGC1 alpha molecule. So just to confirm that this is important for PGC1 alpha activity, if you add PGC1 alpha into cells, you get more mitochondria, and as a result, you get more oxygen consumption. You can see that here. When you don't have active P38, you add PGC1 alpha, you get more oxygen consumption because you have more mitochondria. Now what happens when you add PGC1 alpha and you activate P38? The result is that you get a further doubling of oxygen consumption because you've increased mitochondrial mass even more. Now what happens if you mutate those three sites, the 262, 265, and the 290 whatever, what you can see is you still get the activation by PGC1 alpha. PGC1 alpha still activates, increases mitochondrial mass, but now when you add the activator of P38, you don't see a further increase in PGC1 alpha. So in order for P38 to increase the activity of PGC1 alpha, what it has to do is it has to phosphorylate it at those three sites. And so what that tells us is that phosphorylation of PGC1 alpha by P38 increases PGC1 alpha activity. So how does it do it? Well, interestingly, where these 3 amino acids are in PGC1 alpha are within the repressive domain. And the repression domain is a domain that binds to this protein RIP140. And so the current thinking is that when you get stress and it activates P38, P38 phosphorylates PGC1 alpha, and now PGC1 alpha, because you've changed the charge, can no longer interact with RIP140. You've removed that protein interaction, and now the existing full-length protein is far more active. All right? So you would expect then, after exercise, immediately after exercise, you get P38, phosphorylating PGC1 alpha, decreased interaction with RIP140. But 3 to 6 to 9 hours later, when you're now making this truncated form of PGC1 alpha from the alternative promoter, you no longer have the repression domain. P38 phosphorylation is no longer necessary to get that higher level of PGC1 alpha activity because it already doesn't interact with RIP140. So the smaller truncated form that you make after exercise, that doesn't need to be phosphorylated by P38, and that's good because P38 phosphorylation is already, or P38 activity is already back down to 0 by the time you make the new shorter form of the protein. So it's a nice way that you can get quick activation of the full-length protein that's there, and then it doesn't matter if it's there later when the truncated protein is coming up because this interaction has already been disrupted.